All right. So first things first, why the new cheat sheet? If you're wondering why I just gave you a cheat sheet, you didn't do the homework last night. Because on the back of your homework from yesterday, on problem 118, now, a lot of us probably know about decks of cards, but not all of us. Guys, growing up, if I was with my grandma, I wasn't allowed to play with cards because she thought they were evil. Like, no joke, my grandma was old school. So we'd never, like, you know how some grandmas, like, sit around and play, like, bridge or, like, whatever? Like, nah, no card games for my grandma. So if you were in a family like my grandma, you might not know about decks of cards. So I laid out all of the information here, and even if you know about decks of cards, some of you are wrong. Like, sorry to tell you, well, not sorry to tell you, because that's my job, but if you think there are 54 cards in a deck, you're wrong. If you include the jokers, sure. But for mathematics, we do not talk about jokers.
Most games don't have jokers.
So one purpose is some games need extra cards that you like make the joker into a different card. Other purpose to have jokers in the deck is if you lose like the 5 of diamonds on the joker, you can just write this is the 5 of diamonds, and like your deck, is not ruined by losing a card. So in a deck of cards, there are 4 suits, right? Spades. Guys, I was way too old when I learned this. A spade is another word for a shovel. These look like shovels. That's why they're called spades. Hearts. I shouldn't have to explain that to you, but that doesn't actually look like a human heart, because a human heart is just whatever. But that's what we've decided a heart looks like, right? Human heart's really just like a blob. It's more, it's got chambers and everything. But diamonds, that one makes sense, right? And then clubs, clovers, right? Some people call them clovers, but they're clubs, is what we call them in decks of cards. Depending on the game you're playing, ace might be low, ace might be high, but there are no ones, right? So it goes 2 to king, and there's also ace. On the bottom of that page, then there is information about dice rolling, because most times that we talk about dice, we're talking about rolling 2, because, guys, we're already pretty good talking about a single die. Look at this paper with me, guys. This table shows you the actual, result, the number you get. Like, if you're playing Monopoly, right? This table shows you the outcomes. Because if I'm looking at getting a 7, how can I get a 7? Sam? 6 and 1. How else? So 6 and 1, 5 and 2. How else? 4 and 3, 3 and 4, 2 and 5, 1 and 6. 1 and 6 is different than 6 and 1. I got in a really big argument with my father-in-law about this because he plays craps when he goes to the casino. And he was like, yeah, there's 3 ways to roll a 7. I'm like, no, there's 6. He goes, well, no, 1 and 6 is the same as 6 and 1. I'm like, no, it's not. Mathematically, it's not.
How?
Because if you imagine one of your die is green and one of your die is red, a red 6 and a green 1 is a different result than a red 1 and a green 6. Mathematically speaking, there are 6 ways to get a 7. I doubt anyone will argue with me that there's only one way to get a 12. But so that's because there's only red 6, green 6. If you switch their places, it's still red 6, green 6. Right? Red 1, green 1. Green 1, red 1, right? Like they're the same thing. But a red 1, green 6, red 6, green 1 are 2 different things. All right, now that we've covered the cheat sheet, dive into Desmos. Say if you have a tiny bit of catching up to do because we started this yesterday. So if you need to chat with Lane about what we talked about yesterday, feel free.
Can I show you what, you know how, on question 6 where it said, try to find, the way to show...
The mouse elephant one, gentlemen. You at least need to be in the activity for me to think that you're talking about the activity. Mouse versus elephant. So actually, let's do this as a group to help Safe catch up since he's been sick. Yesterday we made it to this slide. And we started tweaking it. Who can tell safe, like what we said about what's wrong with this slide? Sure, right?
I remember I had to leave early yesterday.
Oh, so then for safe and for lane, what did we say is wrong here, and how are we going to fix it? Emery?
The data is too much this side, so like
Yeah, the
they're
data's
not
all
on
compressed.
but they're all like near zero.
So what do we say about this point?
That one's an outlier, so we're just gonna get rid of it.
We call that an outlier, and we're going to not care about that. So one option, I'm not saying take this option because it's not the best, but one option that spreads my points out a little bit. I did negative 1,000, 5,000, negative 325. I can still get better. I want to know, like, I want you to tell me when you think you've dialed in the graph the best possible, like that your points are as spread out as they can be. Arfon, you think yours?
So I did negative 1,000.
I'm going to show it. So hold on, stay on that screen. Or go back to that screen if you need to. Because you guys know I'm in Dino. Like, that can't be a surprise to anyone. If this loads. Actually, I can show it from Desmos too. And I think that one might work better. Arfon. Alright. Ooh, Arfon got this point way out to the edge. Now, if we're going to give some critique, does Arfon need this much negative?
No.
We could probably take some of that away and do like negative, I don't know, like a couple hundred maybe, or negative like 300 or 400, but I feel like that's a lot of negative. I know yesterday we talked about leave some negative so you've got some space over there, but we don't need that much.
I just fixed it. Negative 200.
Can we still see? Yeah. Nice. So these are all, so can we better tell where these points are? Kind of. If we get rid of this other point, we could spread these out even more, right? So that's the decision now, is like, do we want to keep this point or not? But all right, after you've played with this a little bit, move on to the next slide. Sophia?
Well, I have one too.
Oh, you want me to show yours?
I don't know if it's good,
So you got a little bit too much space up here.
but I know.
So we would probably want to trim down the max on the Y. So maybe like 30. Yeah, and still I think we could probably do 25 because we want to spread things out as much as we can. So I still think you got a little bit too much dead space, but it's pretty good.
There.
It's pretty
I
good.
changed it again.
Jack, you said
Now
yours?
It's perfect. It's perfect now.
Ooh. So now my one critique. We can't really see the axes when Jax zooms in because we made it like pretty much zero. So we can see the one axis. Raiden, stop what you're doing. We can't see the x-axis, so I would make your y something negative. Like even just like -2. But then we'll be able to see the x-axis, right? Because we go to a negative x value, we can now see the axis. Aside from that, this is pretty darn good. Man, so if we throw this point away, if we throw that point away, what would we probably set as our maximum? Well, how far is this?
What, like 1,500?
Yeah, let's try that. See if that, let's just like get rid of the other outlier. Let's try 1,500.
It's like that's perfect.
Ooh, you want me to go to yours, Sophia?
Yeah, I don't.
Ooh, yeah. So guys, now we can really see the differences between some of these. Now, what if we get rid of one more outlier? What could we then make the max? Maybe just like 600.
You could do 550.
Ooh, so if I change Sophia's to 550, There's one outlier gone. Another outlier. Ooh, now the negative is far too negative.
Then
So I'd go like negative 50 maybe.
no,
Now we can actually see where these points are. All right, we could play with this for a while. Let's move on. Ha ha ha.
I was already.
Okay, if you were past that, you can go past it again now. We're now at this graph.
Wait.
At least I think. Or no, I'm one slide too far.
Yeah, we're on 7.
Yeah, so we should be looking at this now. The original question was, what do you think? I want to see your guys' results. So if you're past this slide, I should be able to see a typed result from you. That I was right. Size does matter. The bigger is the faster it goes. Yes, because bigger has bigger legs. Well, yeah. See, this is what I thought. Bigger animals, bigger legs. But if you're going to argue against bigger animals having like faster speed, length,
Here's what I thought from. Can I explain why I thought bigger animals were faster?
sure.
Cause like, I thought about when I was little. Like when I was a little kid, I had to run to keep up with my dad, but he was taking like just walking. One big step.
Yeah.
Was equal to like 100 for like an elephant. Like one elephant step is probably like 100
Compared to mouse, right? Yeah.
So if an elephant is continuing to take that step,
Now, but if you think about like
I was thinking
Bigger
about
animals
weight.
have like more lumber.
weight,
Because
right?
like elephants are really heavy. It's like it's harder for them to like carry all their body weight at that fast, but they are fast. But mouses or mice,
Mises.
yeah.
So
What if they got thumbs going?
the bigger is the fat. Guys, I don't know what the right answer is here. Yes, there's a relationship. I think bigger animals might be slower. I was right about most bigger animals. Ooh, okay. Most bigger animals. So then when we come here to Juan's hypothesis,
Spider monkey.
I think what you'll see is this.
Yeah.
So take a minute, type your feelings, your thoughts about what Juan did. I want to see this typed, right? What is up? Did Juan do it well? Does Juan need some advice? I just want a one-word answer. Is Juan's graph good? So like yes or well, not the typed, but out loud right now. Is Juan's graph good?
Yeah. Sure.
No.
What? Oh no, it's not. Are we supposed to type one?
Mm-hmm.
Oh wow, I see what you mean. Why is everyone just saying? Because it's not good.
Well, but why? Sorry, in the typed answer, I want you to tell me why. You don't have to tell me exactly how to fix it. I mean, I still get confused by your guys' vocabulary when you just make up words, but I mean, mid because it's spread out good, but it's not really accurate. Change how the animals are related. No, change how the numbers are on the graph.
Here, look at that.
No, ooh, the numbers are not in order that makes sense. 2 then 45. 2 then 45. Oh, 2 then 45.
I just noticed that.
And
Then, yeah, like.
Wait, so what? Can somebody volunteer to tell me like what he did wrong? Like what? How would we like use some math vocab to tell Juan like what he goofed up? We need to determine what? We need to decide. We need to determine a scale, guys. Juan needs a scale.
You don't go from 2.5 to 11.
Yeah,
It should be like 2.5 to 5, then 5 to 7.5, and then 2.
Guys, look up here real quick. If Juan says that this is 2.5, because obviously this is 0 right here, then this is also supposed to be 2.5, and he definitely did not do that. Right? So we need to figure out a consistent scale. So after you tell him what he did wrong, now we have the chance to figure out, like, well, how do we get it fixed for him? So keep rolling. I'm kind of watching you guys over here from my teacher view.
Oh, so now we type, like, also apply how do you change it.
So they restrict us to a 10 by 10 grid, which is a lot of times what I end up putting on paper is like a 10 by 10. If you got 10 boxes vertically, 10 boxes horizontally, what should we make each box worth, right? That's the scale is what each box is worth. How high do we need to get on the y-axis? 15.5, or a little bit past that. How far do we need to get on the x-axis?
It's just 140.
140, or a little bit past that.
I said 150. Oh, no. That did not work.
If you didn't get your graph paper out, I thought we had an agreement. I thought we had a habit going, but you're probably going to want your graph paper out. Like the thing we've been taking notes on. Guys, this is directly on your homework. So if you take this note now, it will help you a ton when you get to this problem on your homework.
I got it.
I have an extension cord, but it won't reach back there. You're going to have to move. Like, you're going to have to come up to the round table.
Do 20 and 5. No, I did 20 and 5. 20 and 5 then. No, that's what I know.
Well, you're going to help us answer some questions. But then you could probably work on your homework. Is a pretty safe thing. So, when we are graphing, so this whole little section, I think this is probably big enough. When we're graphing, we can determine the scale for an axis. Anyone know? I'm setting up a little division bar. Sophie? So you're really, really close. The number we want to get to, so like the number that is really like our maximum, I guess I should have probably written that like max number, or slightly higher, or just over. Divided by, anyone? Lane, put it away, it's distracting you. Our maximum number, or just over, divided by the number of boxes. So, for example, how far do we want to get
on our y-axis? Yeah, we don't, 15.5 is kind of a messy number because it's a decimal and whatever. So if I was you, I would maybe overshoot to like 18 or maybe just make life easier, and do 20 as the max that we're trying to get to. So, well, here's the thing though. We have 10 boxes, right? So Jack said he said 17, but 17 divided by 10 is going to be a little messy. If we scale out the boxes of 1.7, I kind of like the boxes being worth 2 better. Right, so there's our Y scale. Oh, I'm not in Desmos. But our Y scale, we could put a 2 here. Our X scale, how far do we want to get out to that gorilla? 140, so maybe slightly past that. 150 divided by how many boxes? 10. They said we're a 10 by 10 graph. So what's 150 divided by 10? 15. So I think we need to scale our y-axis by 2 and our x-axis by 15 on the other part of my paper.
Oh, I did 20 there.
You could do 20 for the x-axis, but you're going to leave a decent amount of empty space. We want to try to minimize our empty space. If you chose not to write this down, that's a choice you're going to have to live with. I'm leaving it up there for a couple minutes. Very hopeful you will actually care about it. Because it's directly what a question on your homework asks you. Maybe you should have looked at your amount of power before it got to the point of being dead. Do you have your charger?
Yeah.
Safe's got the power strip, so you can plug into that. He can actually swing it around back of him probably. Hey!
Why'd you pause it?
Look at your homework 232. Look at problem 126. Do problem 126 right now. While it's fresh in your brain.
What do you mean by X, Y, X?
So, X, Y. Guys, if we need to make this note in our notes, I guess I didn't think about this. This is stuff that I figured that 6th grade covered. But when we're graphing our axes, and guys, most axes have it on it. The horizontal is our X. The vertical is our Y. Right? So if you need that reminder, you could probably just even put that on your, so like X, Y, it's most of the time your axes are labeled as X and Y.
They didn't have it in 6th grade. We had to figure it out ourselves.
Interesting. So if what you're trying to get to is 132, are we really going to use 132 or pick a nicer number?
Use
140.
140 could work. What would even be nicer than 140?
150.
150? I feel like, so guys, if we did 140, and guys, we could play this out a couple different ways. I'm going to call this example A. If we did 140, what are we going to divide that by based off this situation? 20, because we have 20 grid units. Ooh, what's 4? Because the zeros will cancel. What's 14 divided by 2? 7. I mean, that's not bad. Actually, I think 150 is worse. Option B, if we do 150, what are we dividing by? 20, right? Because they tell us there's 20 grid units. What do we get there? 7.5. So, I mean, I guess 7.5, then 15. The 15 would be nice.
And then 30. Wait,
And then 30 would be nice, right? Because we like the next two box. So you decide which you want. But like either of these could be right. Now, if you do 130 divided by 20, that won't get you far enough, right? We always got to round up, go a little bit past. Questions?
so you don't draw it, you
Hey,
just
look.
write it.
A probability question that your cheat sheet is going to help you on.
Okay.
I'm debating what to do with our final 13 minutes. So give me a moment.
You do Jenga.
Yeah, I know. I'm debating if we're ready though. Like I'm checking if there's anything else I needed to cover from this final lesson.
Are you gonna come back to the Mount Grizel tomorrow?
No. So it's unpaused now. I only paused it to get your attention. So today is our final time working on Mouse v Elephant.
Wait, are we like working on questions for this?
So again, Desmos is so we can learn through experiencing, right? And like making mistakes as we go and whatever. Desmos is never really going to be homework. And while we want to learn and do well, it doesn't really have to be right. Like I'm not looking for right answers in Desmos. I'm just looking for us learning. Yeah, we should talk about this because it'll help you on your homework. Yes. So, what mistakes she made. So you could just write it down here if you want. So you could, guys, you can always get separate paper for your homework. So if there's not enough space, you can always use graph paper. Whew.
Bless you.
Thank you. I have a question for you. You do? Okay, good. So if we chose 15 and 2 for our scales, hopefully Juan's graph ended up looking like this. Anybody have questions about how this is better for Juan's graph? We got even spacing, those even intervals. We fixed it, everything spread out like it should be. So what could we say from this graph, if you're trying to talk about results or like findings, what could you say based off this graph? Like, who's the fastest animal? Spider monkey. Are they the biggest animal?
No.
Definitely not. Who's the biggest animal? The gorilla. Are they the fastest?
No.
But are they that much slower? Not by much, right?
The chimpanzees.
Do you guys feel awkward that we're on this graph?
Yeah.
Chimpanzee, orangutan, spider monkey, human.
Okay.
I know, we are
They
animals.
run
right?
on with this. At least we know that we can run away from an orangutan.
Fair.
But I don't think you can.
An ostrich don't.
No, we cannot.
Ostrich run at like 60 miles per hour.
All right, so
He just run at 90.
we have been hired by a smoothie shop.
No.
Yes.
The chocolate really tastes pretty good. I would
So here's the data they collected from their first 12 days in business. They want us to create a graph for them, and your partner puts this graph in front of you. I want you to turn to your partner and tell them if their graph is good, or if not, what they need to fix. Talk to each other. You want to be my partner, Steve? All right, is it good? It looks beautiful. Straight line. Gorgeous.
Is it good though? Why is it not good? It's not scaled. Yeah, it's not scaled.
Wait, if it's going, that's
We're gonna probably not anymore.
the numbers.
On your graph paper. On your graph paper, you'll need 10 boxes tall. So if you're at the bottom of your page, you might need a new page. I know this was from way before, but I'm just picking up. Actually, I should probably just start a fresh page. Let's stop trying to be so... Let's make a 10 by 10 because that's what we normally do. So if you want, you can start at the top and say like, all right, 1, 2, and count down 10 to make sure that I give myself enough space. And 10 wide, just because that's the standard size of a graph. I just now realized I've had my music on the entire class. Same. No, but I mean, you guys have been fine, so. So, what we now need to do is take this data and fix it and put it on a new graph. So, do you want to look at this data from his graph, or would you rather me show you the table? Yeah, the table's probably better, right? So there's our table. I'm going to clean it up and just copy out. Now hold up. Here's the main question. They want us to make an expectation for day 20. So even though his table only goes up to 12, since we're trying to make an expectation for day 20, we should probably make our table go up to day 20. Hey, Sophie, you sure look a lot closer to taking a nap than you do graphing these points. So maybe adjust what you're doing, like get a bit more vertical than you are. All right, so here's his data. But we actually want to go to day 20 to be able to make that prediction. We are going to do like he did and put days on the x-axis and smoothies on the y. So days. Leave yourself space to put the numbers, though. And smoothies. So if our days want to go up to 20, and we have a 10 box space, what scale are we going to choose for the x-axis? If we want to go up to 20, we have 10 boxes. 2. Yeah, 2, right? Because 20 divided by 10, and if you want to make that work off to the side, we're doing 20 divided by 10 equals 2. That's how we get the scale. So 2. Hey guys, do I have to label every 2? No. There's 4 right here, but do I have to label it? No. 8, 10, 12, 14. Now you could label all of them. And 20. Now, on day 20, do you think they're going to sell 38 smoothies, or do you think they're going to sell more? What trend have we been seeing? People are finding out about the smoothie shop. People are saying, hey, it's delicious. Go get one. So how many do you think they'll sell on day 20? What do you think?
45.
I mean, they had a 10 smoothie jump in 2 days. I think more than 45.
People went to go buy it because they heard the smoothie shop was closing down. Oh,
So I'm saying at least 50. I would even maybe go farther than that. What if we think optimistically and we're like, okay, they might sell like 60?
I don't think you could do
Okay, fine. You guys all disagree. Let's say 50.
22.
That was my idea.
All right, 50. So how are we going to scale the y-axis? If we want to get to 50 and we have 10 boxes, sorry, people yelled at me for saying 60, so now we're going to use 50. I really hope I'm right. 50 divided by what? 10. So now we get 5. So 5, 10, 15, 20, 25, 30. Oh, and I still do have some more paper above my graph, so in case I'm right and we go farther. All right, now let's graph these points. You have the table up there. Bless you. Day 3. Well, if each of these is 2, day 3 would be in between. It's a day 3 and then 3 smoothies. Ooh. Probably down here. Day 4, they sold 5 smoothies. That point's easier to graph. Day 6, they sold 10. Ooh, that's a nice, not bad to graph. Day 9, how many did they sell? 20. Yeah, 9 would be right in between the box, right? And guys, remember, this is all recorded. If you're doing your homework and you start struggling on this stuff, come back and watch what we did in class. Day 10, they sold 28. So we know where 25 is, we know where 30 is, so we're closer to 30 than we are to 25. Day 12, 38. And the prediction we want to make is at day 20. How could I figure out the predicted point here? I got a ruler, so I've been using it. I forget if our class has talked about it or not, but there's this thing called a line of... It's not the line of perfect fit, but it is the line of best fit. So what we're going to do here is set up a line of best fit. If you want to make this note in your notes, it would be really good for you. Line of best fit. Not perfect, but best. And the goal with that is try to match your points. Now, are these points in a perfect straight line? No. So I want to try to like balance, and this is why we said a clear ruler. I want to try to have equal points above and below. So if it's on, it doesn't really count as above or below. So currently, like this, because if you look up at the screen, I have 2 points above, 2 points below, and these 2 points are just about on. I could go a little steeper if I want. Probably. But try to use your ruler to figure out what line could pass through like the points pretty nicely. A couple points are above, a couple points are below. And then you tell me, what's your prediction for day 20? I know we're out of time, but I want to prove to you I was right. What's our prediction for day 20? Oh, hey, look, it's 60. I was right.
You knew it all along, though.
Have a great day. Go to Connections.
You're acting like a 3-year-old.
Yeah, whatever.
Did you just say I'm acting like a 3-year-old?
Yeah.
I don't know if 3-year-olds can say nada nada boo boo.
They do. They can.
Okay, well, then I guess you're right. I can't really argue against that. So, a histogram.
I like totally forgot about it.
I'm actually going to leave the recording. So you can come back to this conversation if you want.
What about?
So a histogram is a
way to represent data in bins. Now, don't ask me who decided to call it bins, but each of these columns we refer to as a bin. So we can actually start the histogram wherever we want, because it's not like an XY graph that we need to have 0, 0. This needs to start at 0. The frequency axis needs to start at 0. But what we're going to start at for the x-axis, which really isn't the x-axis here, but is whatever our lowest number is, and a tiny bit lower than that, just to make it a nice number. So the lowest number here might be 62, but they started at 60 because it's nicer.
Lowest number here is 34, so would we go lowest number 30?
Yeah, so you'd start at 30, and then they tell you how wide to make your bins.
So, there it is. Right here.
Why are we talking about Roman
So then what would the next one be? Do I just like count by a certain number? Like, would I-
Bin width of 15.
Ooh, so I
So-
just count by 15?
So we will go from 30. You have to leave my classroom. Then, we pick like how many boxes we want so that we can make it consistent. So I'm just going to do 3 boxes for each of these.
45.
And then 60, and then 75. So then, you make those columns as tall as the frequency, which is how many of those numbers there were. So between 30 and 45, 1, 2. So that frequency is 2.
Yeah, y'all can come.
Yeah, you're good. We're just doing, get in your teams.
Oh, wait, but then how do I label these? How do I know what it's what?
Hold on, I gotta at least put Desmos, or at least put that in front of me. So then between 45 and 60, 1, 2, 3. So that one will be 3 tall. You know what I mean? Because there were 2 in here, there were 3 in here. Does that make sense?
Yeah, but how do I know what to label?
Ada, you can pick whatever team you want. How to what?
How do I know those guys? Like, totally unique.
You just make it. So 1, 2, 3, 4, 5. Like, so we might want to check how tall do we need to get. So there's 2 there. There's 3 there. 1, 2, 3, 4, 4. Right, because 75 is my next. So 1, 2. What's after 75? Well, that's going to be 90. So that's the rest of them. 1, 2, 3, 4, 5, 6. So I think this is going to need to be 6 tall. But as always, I would advise graph paper. I would always do